Hello everyone, myself Assistant Professor Vatsal D. Patel from Civil Engineering Department working at Mahatma Gandhi Institute of Technical Education and Research Center NAVSARI. Today we are going to discuss about tachometric surveying and our today's topic is methods of tachometry. So be ready with your pen and paper. So let's start with the introduction first. Tachometry is a branch of surveying in which the horizontal and vertical distances are determined by angular observations with a tachometer. The chaining operation is completely eliminated in this method, but it is less accurate as compared to chaining. So if we talk about this, tachometry survey is adopted in rough and difficult terrain where direct leveling and chaining are either not possible or very tedious. Through less accurate, this method of surveying is very rapid and convenient. If the purpose of a survey does not require a very high accuracy, the method of tachometry survey can be used with an advantage. The relative error under favorable conditions will not exceed 1 in 1000. So let's see the purpose of tachometry surveying. So tachometry is defined as an optical distance measurement method. The primary object of tachometric surveying is the preparation of a contour plans. It is used with advantage over the direct methods of measurement of horizontal distances and differences in the elevation. So here some of the purposes are listed, like preparation of topographic maps which require both elevation and horizontal distances, survey work in difficult terrain where direct methods are inconvenient, to measure the horizontal distance at which the distance measured by the tape or chain is difficult, to prepare contour map, and lastly location for survey for road, railway, reservoir, etc. So these are the purpose of the tachometric survey. Okay. So let's see the principle of tachometry. So the principle of tachometry is based on the property of isoscale triangle. It means that the ratio of the distance of the base from the apex and the length of base is always constant. So let's understand it with one image here. Okay. So first of all, let us remember the statement of principle of tachometry. So in isoscale triangles, the ratio of the perpendiculars from the vertex on their bases and their basis is constant. So here PQR, which one? This one, PQR, same as PQ dash R dash, and lastly PQ double dash R dash are all isoscale triangles whose bases are respectively QR, Q dash R dash and Q dash R dash, and their vertex is at P. Which point? This point at P. And here PO, PO dash and PO double dash are the perpendicular to their respective bases. So then if we talk about the equation, PQ upon QR is equal to PQ dash, PO upon QR is equal to PO dash divided by Q dash R dash is equal to PO double dash divided by Q double dash R double dash is equal to constant, or say it is denoted by capital K. So our equation of K will be 2 cot alpha by 2 because our angle here is alpha by 2. We have mentioned it in the image. So where alpha is equal to apex angle, K is equal to constant which is given by F upon I, where f means focal length of the objective and I is equal to stadia intercept. So now let's see the instrument used for it. So the main instruments used in tachometry are a tachometer, and the second one is a leveling or Stadia Road. So let's start with the tachometer first. A tachometer in general sense is a transit theodolite having a telescope fitted with a stadia diagram. A telescope equipped with two horizontal hairs called stadia hairs in addition to the usual central hair. The additional hairs are equipped from the central one and are also known as the stadia lines. So here are the types of stadia diagram commonly used are shown in figure. So you can see all in the image. Okay. So various type of stadia diaphragm will be there. Next is a leveling or stadia rod. The stadia rod or staff used with tachometry may be usual type of leveling staff having least count of 0.005 meter. Stadia rod is usually in one piece, but for easy transport it may be a folding type. So here you can say both type of it. So further discussing about it, it is 3 to 4 meter long and 5 centimeter to 15 centimeter wide. The graduations are bold and clear with a least count usually less than the least count of an ordinary leveling staff. The stadia rod should be as light as possible. So you can see it image here. So next is methods of tachometry. These are all very important. So be sure you remember each and every method. Okay, so let's start with the first one. So the underlying principle common to the different methods of tachometry is that the horizontal distance between an instrument station and a point as well as the elevation of the point relatively to the instrument can be determined from the angles subtended at the instrument station by a known distance at point and the vertical angle from the instrument to the point. So you can see its arrangement in the figure. So the various tachometric methods employ the principle in different ways and differ one another in methods of observation and reduction, but may be classified under two heads. First one is the stadia system and second one is the tangential system. So let's discuss it. So the stadia system, in stadia system the observation are taken with the stadia wires of the tachometer, and in the tangential system the angles of elevation are measured from instrument station to the points with a theodolite, and their tangents are used to determine the horizontal of the telescope. So let's start with the stadia method first. So in the stadia method, a tachometer is set up at station P. So here you can see it in the image, this one at P. Okay, and a staff is held at another station, say Q. Which station here? Q. Okay, so from figure we will understand now each and everything. Okay, so the staff intercept S. Which one? This one. Between the upper stadia hair and the lower stadia hair is measured first. Then the vertical angle theta is also measured. The horizontal distance, which distance? This distance, capital D. The horizontal distance, capital D, between P and Q, and the difference of elevation. Okay, this difference of elevation of P and Q is calculated from the staff intercept S, this one, and the vertical angle theta by using formula. So different formula will be there. Okay, so which we have discussed is written here. Okay, so in the stadia method of tachometry there are two methods of surveying. First one is fixed hair method and second one is movable hair method. So if we talk about fixed hair method, in this method the distance between the stadia hairs is fixed. When a staff is sighted through the telescope, its certain length is intercepted by the stadia hair, and from Tin's value of staff intercept, the distance from the instrument to the staff can be determined. The staff intercept varies with its distance from the instrument. This method is most commonly used in tachometry. So in fixed hair method, the upper and lower stadia hair is fixed, or say stadia interval is fixed. The distance between the upper stadia hair and lower stadia hair, called stadia interval, say it is denoted by small I, is fixed, and the value of the staff interval, say capital S, varies with the distance. So there are mainly three cases in this method. Case 1, when the line of sight is horizontal and staff is held vertical. Second one, when the line of sight is inclined and staff is held vertical. There will be two conditions there. First one is considering the angle of elevation, say plus theta, and second one is considering the angle of depression, say minus theta. And case 3 is when the line of sight is inclined but staff is held normal to the line of sight. So let's see the case 1 first. So when the line of sight is horizontal and staff is held vertical, so you can see its arrangement in the figure. Okay, so let us understand the figure. So first of all, O, capital O, is the optical center of the object glass. Next, wait a minute, small p, q, r are the top, axial and bottom hair reading. Next, PR, with distance P to R, small p to small r is equal to I, small I is equal to length of the image. Next is small f, this distance. Okay, so small f is equal to focal length of the image glass. Next is staff intercept. So it is here, it is denoted by capital S. Okay, we have already known it. So staff in intercept on PQ. Okay, PQR. So from this we will get the staff intercept. So mainly on PQ it is measured firstly for this method. Okay, next small x. Small x is equal to the horizontal distance from O to the staff, and second one x dash is equal to horizontal distance from O to the plane of the hairs. Next is small d, this one, small d is the horizontal distance from O to the vertical axis of the instrument. And lastly, if we talk about capital D, is equal to horizontal distance from the axis to the staff. So we have mentioned each and every term here. Okay, so I have already written it here. Okay, so these all cases are very important. So I hope you write down each and every cases, because it is very important for your examination. Mainly this type of theory comes in your examination, so be sure you remember it. So here all the criteria, all the denotation are mentioned here. So the rays say POP, which means capital P, capital P, O and small p, and Q, O, Q are the straight line. Okay, so the triangle POQ and P small oq are similar, hence x divided by x dash is equal to s upon I. But x and x dash are conjugated focal length, say distance. So 1 upon f is equal to 1 upon x dash plus 1 upon x. So multiplying both by fx, the equation will be x is equal to x divided by x dash into f plus f. So substituting the value of x divided by x dash is equal to s upon I. Equation will be x is equal to s upon I into f plus f. So if we add c on both the side, x plus d is equal to s upon I into f plus d, but x plus small d is equal to capital D. So equation will be capital D is equal to f upon I into s plus into bracket small f plus small d bracket over. So the constant k is equal to f upon I is known as the multiplying constant or Stadia interval factor, and the constant c is equal to f plus d is known as the additive stadia of the instrument. Okay, so this is the first method. So I hope you write down this and this. Okay. Next, if we talk about vertical distance formula, when the line of sight is horizontal, v is equal to 0. This will be the only equation. Next, if we talk about case 2, when the line of sight is inclined and staff is held vertical. So consider an angle of elevation say plus theta in the image. Okay, so remembering the image. So let this capital A is the instrument station and A dash upper side is the position of the instrument axis. Next, P is the staff station. Next, D, C, B are the points on the staff cut by the hair of the diaphragm. So you can see it here. Okay. Next, angle C, A dash and K. Which angle? C, A dash, K. This angle. Okay. Is an incline of the line of sight A dash C to the horizontal. Next is BD is equal to S. Here is S is the staff intercept. So say difference between the top and bottom hair reading. So BD, this distance B and D, okay, is equal to F staff intercept. Next is CP, which capital C and capital P. CP is equal to small h here. Is the central hair or axial hair reading. Next is A C dash is equal to this all distance from A dash to C. It is denoted by capital L. So capital L is the distance along the line of collimation from A dash to C. Next, A dash K is equal to horizontal distance, say capital D. So D is the horizontal distance from the instrument to the staff station P. Next is CK. So CK is equal to V, which is the vertical distance from the instrument axis to point C or say central hair reading. So draw a perpendicular line through C to the line of sight is A dash C. Okay, perpendicular line, so that it cuts the A dash D in D dash. So it will cut A dash D in D dash. Okay, and A dash B in B dash, and is the projection of DP perpendicular to A dash C as shown in figure. Line BD is perpendicular to the line A dash K, and B dash D dash is perpendicular to the A dash C. Okay, so we have seen all the criteria in the image. So already I have it listed down here also, so you can write it down from here. Okay, so be sure you write down each and every one, every step for it and every notation for it. So talking about the angle, so angle DCD dash is equal to angle BCB dash from the figure, which is equal to, and angle DA dash C is equal to angle BA dash C is equal to beta. So beta will be here, okay, this one. So angle A dash D dash C is equal to 90 degree minus beta. So angle D dash C will be 180 degree minus into bracket 90 degree minus beta bracket over. So further it will be simplified into 90 degree plus beta. So angle B dash C will be 90 degree minus beta. So from the triangle SD dash C and B dash C, D dash C is equal to DC, say DC cos alpha, B dash C is equal to BC cos alpha. So DC dash plus BC dash is equal to DC cos alpha plus BC, sorry, my mistake. So let us understand again. So from triangle SD D dash C and B dash C, D dash C is equal to DC cos theta, B dash C is equal to BC cos theta. So D dash C plus B dash C is equal to DC cos theta plus BC cos theta. Further D dash B dash is equal to into bracket DC plus BC bracket over into cos theta. So D dash B dash is equal to DB cos theta. So it is further simplified into this D dash B dash is equal to S cos theta. All are derived from the image, okay. So horizontal distance, say capital D, when the line of sight is horizontal, then D is equal to F upon I into bracket D B bracket over plus into bracket F plus D bracket over. So here dB is equal to S, so equation will be D is equal to F upon I into S plus into bracket F plus D. Now if we talk about incline distance, A dash C is equal to capital L. So further it will be simplified into F upon I into bracket D dash B dash bracket over plus into bracket F plus D bracket over. But here D dash B dash is equal to S cos theta. So equation will be L is equal to F upon I into bracket S cos theta bracket over plus into bracket F plus D bracket over. So horizontal distance D is equal to L cos theta. So further if we put the all values, so D is equal to L, which is equal to F upon I into bracket S cos theta bracket over into bracket cos theta bracket over plus into bracket F plus D bracket over into bracket cos theta bracket over. So D is equal to F upon I into S cos square theta plus into bracket F plus D bracket over into cos theta. So here F upon I is equal to K and F plus D is equal to C. So putting those values, D is equal to F upon I S cos square theta plus into bracket F plus D bracket over into cos theta. Now if we talk about vertical distance from triangle A dash CK, where CK is equal to V, which is equal to L sin theta. So put the value of L is equal to F upon I into S cos theta plus into bracket F plus D bracket over. So equation of V, or say vertical distance, will be F upon I into S cos theta into sin theta plus F plus D into sin theta. So further simplifying it, V is equal to F upon I S sin 2 theta by 2 plus into bracket F plus D bracket over into sin theta. So here F upon I is equal to K and F plus D is equal to C. So V will be Ks sin 2 theta by 2 plus into bracket capital C bracket over into sin theta. So which is the required vertical distance. Now if we talk about elevation of the staff station for angle of elevation, so elevation of staff station is equal to elevation of instrument plus RL of BM, or say reduced level of benchmark, plus V minus small h. And if we talk about elevation of the staff station for the angle of depression. Elevation of staff station is equal to elevation of instrument plus RL of benchmark, or say reduced level of benchmark, minus V minus small h. So if we talk about horizontal distance, say capital D is equal, it is given by f upon I into s cos square theta plus into bracket f plus d in bracket over into cos theta, and vertical distance V will be given by ks sin 2 theta by 2 plus into bracket c bracket over into sin theta. Now let's talk about the case 3, when the line of sight is inclined and staff is held normal to the line of sight. So considering angle of elevation, say plus theta. So all the arrangement we have already seen. Okay, so horizontal distance formula D is equal to f upon I into bracket s plus into bracket f plus d bracket over. So from the figure, the horizontal distance, say capital D is equal to L cos theta plus h sin theta. So further simplifying it, into bracket ks plus c bracket over into cos theta plus h sin theta. We have already only put the value of capital L, which is ks plus c. Okay, and further it is simplified into ks cos theta plus c cos theta plus h sin theta. Next is vertical distance formula. So vertical distance V is equal to L sin theta. So simply put the value of L, which is ks plus c. So into bracket ks plus c into sin theta. Further it is simplified into ks sin theta plus c sin theta. Now if we talk about the elevation of the staff station, elevation of the staff station is equal to elevation of instrument plus RL of benchmark plus V minus h cos theta. So considering angle of elevation, considering the angle of depression, say minus theta. So horizontal distance formula, or say horizontal distance capital D, will be given by L cos theta minus h sin theta. So simply put the value of L. So into bracket ks plus c bracket over cos theta minus h sin theta. Further simplifying it, it is equal to ks cos theta plus c cos theta minus h sin theta. Now if we talk about vertical distance formula, vertical distance V, capital V, is equal to L sin theta. Simply put the value of L. So into bracket ks plus c into sin theta. So further it is simplified into ks sin theta plus c sin theta. If we talk about elevation of the staff station, so elevation of staff station is equal to elevation of instrument plus RL of benchmark minus V minus h cos theta. So these are the required equation. So be sure you remember all three cases because it is very important for your examination. Okay. Next is movable hair method. In this method, the Stadia hair are not fixed but can be moved by means of micrometer screws. The stall is provided with two vanes or tangents fixed at a known distance apart. The variable Stadia distance is measured, and from this value the required horizontal distance may be found out. The method is now rarely used. So in this method, the Stadia hair, say small I, is not fixed. Stadia hairs can be moved or adjusted by the micrometer screw. In this method, the staff intercept, say capital S, is fixed. The Stadia interval measured corresponding to the staff intercept. Next is the tangential system. In this method, diaphragm of tachometer is not provided with the Stadia hair. Readings are taken by the central horizontal hair. Staff with two targets at a fixed distance, say capital S, is used for taking readings. The vertical angles θ1 and θ2 are measured. The vertical angle and fixed distance, say capital S, are used to determine the horizontal distance, say capital D. So in this also there are mainly three cases for finding distance and elevation. First one is both the angles are angle of elevation, and in this case the staff is held vertically. Case 2, both the angles are angles of depression. In this case, the staff is held vertically. And case 3, when the one angle is the angle of elevation and the another angle is the angle of depression, and the staff in this case held vertical. So let's see the case 1 first. So both the angles are angle of elevation in this case, and the staff is held vertically. So from the figure we can say V plus S, which distance V plus S is equal to d tan theta 1, because the angle here will be theta 1. Okay, and capital V is equal to d tan theta 2. So if we talk about S is equal to d tan theta 1 minus V. So S is equal to d tan theta 1 minus d tan theta 2. Further simplifying it, S is equal to d into bracket tan theta 1 minus tan theta 2. So from the figure, if we simplify the equation, d will be given by S divided by tan theta 1 minus tan theta 2, and V is given by S tan theta 2 divided by tan theta 1 minus tan theta 2. And RL of Q, or say reduced level of Q, will be given by RL of HI, say reduced level of height of instrument, plus V minus H. So these are the required 3 equations. Next is case 2. Both the angles are angle of depression in this case, and staff is held vertically. So here we can say both the angles are in depression. Okay. So from this figure, V minus S is equal to d tan theta 1. So V is equal to d tan theta 2. So S is equal to V minus d tan theta 1. So further S is equal to d tan theta 2 minus d tan theta 1. Further simplifying it, S is equal to capital D into bracket tan theta 2 minus tan theta 1. So from the figure, if we simplified it, D is equal to S upon tan theta 2 minus tan theta 1, and V is given by S tan theta 2 divided by tan theta 2 minus tan theta 1, and RL of Q will be given by RL of HI minus V minus H. Okay, same procedure is here, only the angle change, so value change. Next, case 3, when the one angle is of elevation and the another is angle of depression, and staff is held vertical. So we can see here one angle is in elevation and one angle is in depression. Okay, so from the figure, S minus V is equal to d tan theta 1. So V is equal to d tan theta 2. So S is equal to V plus d tan theta 1. So S is equal to d tan theta 2 plus d tan theta 1. So further simplifying it, S is equal to capital D into bracket tan theta 2 plus tan theta 1. So from the figure, if we simplified it, D is equal to S upon tan theta 2 plus tan theta 1, and V is given by S tan theta 2 divided by tan theta 2 plus tan theta 1, and RL of Q will be given by RL of HI minus V minus H. So these are the all required equation which can be used. So these all are very important for your examination and for the example also. Okay, so be sure you remember each and every case. So here are the important questions which can be asked in your examination, and mainly these are mainly important because in exam it is fixed, one theories always come. So it will be for vertical angle, or say angle of elevation, depression, all cases. Okay, so be sure you remember all cases because it is very useful for your examination and also for the examples. Okay, so here I end my session. Thank you all of you.